Hello class, this is a video tutorial on the pigeonhole principle. The pigeonhole principle states the following. If n plus 1 or more pigeons, more loosely just objects, are placed in n pigeonholes or places / positions, then at least one pigeonhole must contain 2 or more pigeons or objects. I'll demonstrate this to you a little bit more loosely. Here are my objects, they're just dots, and here are my positions, which is just boxes. If I were to fully saturate or fully fill up each of these positions, so here we go, with one pigeon or dot in each of them. Now that it's fully saturated, since there are more objects than there are positions, then this object has to go into a place that already contains one. Hence why if there are n plus 1 or more objects and there are only n number of pigeonholes, then at least one, big emphasis on at least one pigeonhole, must contain 2 or more pigeons. So if we had, let's say, one more pigeon added, let's say there were 11 objects, it has to go into one of these pigeonholes, let's say this one, and it still fulfills this idea of at least one pigeonhole, because in this case there are 2 pigeonholes. Okay, so I hope that kind of gets the idea across of the pigeonhole principle. Now, using this principle, it is possible to more easily answer problems similar to the following examples we're about to do. Now, it may not seem as if it's very clear how it could be applied, but allow me to demonstrate. You can pause the video and give this a go yourself. A school has 500 students. Is it certain that at least one pair of students share a birthday? Now, I know because it's the pigeonhole principle, we're going to have to use it. But for this, we're going to first outline what are our objects and what are our positions or places. So let's outline that first. So what are the objects, or we'll just say the positions first. So the positions. And what are the objects? Now let's think about what this question is asking us. Is it certain that at least one pair of students share a birthday? So let's pretend that this is my birthday, or a birth date. And here's one student, and here's another student. This would mean that they're now sharing a birthday or birth date. Notice how I did that. It kind of already gave you a clue as to what are positions and what are the objects. So the position in this case are the birthdays. And the objects are, well, students. And there we have it. I just realized I spelled this wrong. Birthdays. Now let's try and apply the pigeonhole principle. It says here, if there are n plus 1 or more pigeons, then there are pigeonholes or positions. It will guarantee that 2 or more objects are in the positions. Well, since we're talking about positions being birthdays, how many birthdays are possible throughout the year? Some might say that there are 365 different birthdays, but it's actually possible to be born on a leap year. So there's actually 366 birthdays. Well, according to the pigeonhole principle, we only need 367 n plus 1 birthdays. So because now if we have 367 birthdays, just like I've shown you here, imagine that these boxes were birthdays. Let's just pretend that in 1 year there are 9 days. There's one person born on each day, like so. And this last person, well, no matter what day they're now born, they're guaranteed to share a birthday with one other person, because every other place, or birthday in this case, is now already taken. So, with 500 students, we can just say with 500 students, it is guaranteed by the Pigeonhole Principle, that at least one pair of students share a birthday. And there we have it. What is the minimum number of students needed to guarantee 2 students share a birthday? Well, we've already calculated here. We need 367 students. 367 students guarantees 2 students share a birthday. Now, to clarify this, you could have 100 students, and it is possible that 2 or more share a birthday, but it's not 100% guaranteed. With 367 students, it is 100% guaranteed that 2 or more students share a birthday. This is what the Pigeonhole Principle can be applied to. Okay, so you can go ahead. Let's pause the video and give this one a go. Let's see if you can figure out this by applying the Pigeonhole Principle. So Emma has socks colored red, blue, yellow, and green. She has not organized them in her drawer, so she decided to start just randomly taking out socks one at a time. How many attempts does she need to make to guarantee she has a matching pair? A big emphasis on this idea of a guarantee. Like I demonstrated before in this one, for Emma, she could get absolutely lucky and get just 2 attempts. Take the first one, it's red, and the second sock she get, it could be red, but that's not a guarantee. So just as before, let's figure out the objects and the positions or the places. So let's say this is my first attempt. She could get 1 red sock. Here's my next attempt. She could get a blue sock. Oh, this doesn't quite make sense, does it? If we switch them around, here we go, let's take a look. Red, blue, yellow, and green. In her first attempt, she could get red. In her next attempt, she could get blue. In her next attempt, she could get green. And in her next attempt, she could get yellow. So she's had 4 attempts, and now, because she was unlucky and got 1 of each color, her next attempt, no matter what it is, it's guaranteed to have a matching pair. So as you can count there, 1, 2, 3, 4, 5. We've actually already answered the question here. We need 5 attempts. But for this one, our positions or places are the colors. And the objects are the attempts. Since there are 4 colors, we need n plus 1 objects, so we need 5 attempts. And there we have it. Just answering this in a sentence. 5 attempts guarantees Emma gets a matching pair. And there we have it. Now I've got one last example here, but I'll finish this off in the third video. You can pause it now and give it a go, but I'll see you in the next video where I answer this. Now, overall, hope you got an idea of the pigeonhole principle, where we need to first figure out what are our positions and what are our objects, and really problem solve our way to solving the question. Hope to see you in the next video. Best of luck.